Hello everyone, this is Tsung, and I want to present a paper which proposed by my senior Huang Shen called Whole Body and Texture Preservation Based Virtual Try-On Network. We are graduate students from National Jung University in Taichung, and I'm today's speaker, Tsung. So this is our outline. First, I'm going to start with the introduction, and then I will explain proposed network architecture in detail, and present the experimental and qualitative result. And finally, I will conclude our work. First is introduction. Image-based virtual try-on are really useful recently, especially like current situation, which people couldn't go outside. And virtual try-on, as its name implies, is combine the image of person and clothes to generate the try-on images like the following schematic. However, most of existing virtual try-on network only handle the clothes. So we propose the WBTP virtual try-on network, which can generate the try-on images with no matter clothes or pants. Second section is proposed method. Our proposed WBTP virtual try-on network architecture can divide it into two parts. Geometric matching module, GMM, which is in order to deform the clothes or pants to matching the input person pose. And the other is try-on module called TOM, which is combine the GMM result and person image, and finally get the try-on images. And here is GMM architecture. We individually train the GMMs of clothes and pants. And first, it used two encoders to get the features of person and clothes, and then calculate the correlation between person images and clothes images, and keep entering encoder to get the deformed features, or call the matching pose value theta, and feed into TPS warping to generate the deformed clothes and pants. Second part of our architecture is try-on module network. We first use UNet to generate the person images in try-on clothes, and feed forward the try-on module of pants. Continue. For geometric matching module, we use L1 loss to optimize our network as shown below, regardless of clothes or pants. So the total GM loss function is the sum of both clothes and pants. As for try-on module, the I/O represent the try-on output images which generated from C hat and P hat, means the deformed clothes and pants respectively. And IR is the render person images from dataset, and M is the mask from the ground truth tool. So the total TOM loss function is the output try-on images IO and IT images, which means ground truth, with L1 loss. In addition, to keep the texture of output images, we use the perceptual loss contain 5 layers features from VGG19. Finally, the total loss is the sum of both GNM and TOM loss. And going to the experiment section. First is data set. We collected training and testing images from the internet and totally contains 3,000 person images and 3,000 clothes, 200 pants and 1,000 skirts, where 2,500 are used for training and the other are used for testing, and show like this. And this is our performance. You can see that the final result is good than before input images, and impressive result. And this is a figure compared with CP-VTON. You can also see that our proposed model is better than the other CP-VTON, especially the age of pants or clothes. And finally is our quantitative results. And because the results which are whole body result is too less to find in academia, so we finally decide to use the subjective evaluation instead of objective evaluation. And we find 10 volunteers and provide them 100 sets of test data. And here is the table. You can see that our proposed method is better than CP-VTON. And finally is conclusion. To sum up our presentation, first we propose a new method called WBTP Virtual Try-On Network, which is a learnable image-based full-body virtual try-on pipeline. In addition, our proposed method can try on clothes for the whole body, not just upper body, which makes the bottom more applicable. Moreover, from the experimental results, that our proposed model has much better try-on results than CP-VTON. And in the future, we will try to add different loss functions or network to enhance results better. Thanks for your listening.